Hello guys, so we are going to continue the discussion with respect to EDA and feature engineering. And in this video, I'm going to take a very new data set, and this data set is quite amazing. This is nothing but Google Play Store data set. Now in Google Play Store data set, here you will be finding the data set in a completely different way. Now, how many data sets I'm actually selecting, right, for performing EDA? These all are varieties of data set to just give you a new perspective to think like how we can probably clean the data, how we can probably analyze the data, and how we can actually perform the feature engineering of that specific data set. So these all things we'll be covering. First of all, let's go ahead and understand what this specific data set is all about. So here you can see problem statement. Today 1.85 million different apps are available for users to download. Android users have even more from which to choose, with 2.56 million available through the Google Play Store. These apps have come to play a huge role in our life. Our objective is to find the most popular category. Let's say find the app with the largest number of install. So this kind of information that you can probably see, right? The app with the largest site, etc. So this all information we'll try to find out from this particular data set. And if I talk about this particular data set, it consists of 20 columns and 10,841 records. So this is very good amount of data that is actually present. Now, what all things we are going to do? First of all, we'll start with data cleaning, Now, always remember, whenever you get a data set, it will definitely not be that clean, So you have to probably clean the data. There will be some additional information that will be available, So what all information will be there, we'll try to see it. After probably seeing the data set only, we'll come to know. And then we'll perform exploratory data analysis and feature engineering. So guys, now let's go ahead and read the data set. So obviously I have this data set over here in the CSV format. So I will just go ahead and read this. So before that, I will quickly import all the necessary libraries. Now I think you are very much familiar with all these things: Seaborn, Matplotlib, NumPy and all. Okay. Now quickly we'll go and write pd_read_CSV. And here I'm going to just give my CSV file name. Just a second. I will just copy this CSV file name over here. And this will basically be my data set over here, right? So this is the entire data set. And the reason I've taken this, because this definitely has more than 10,000 records. So if I see df.head, you'll be able to find these records, right? So here you have the app name, you have category, you have ratings, you have reviews, size, installs, type, price, content rating, genres, Android version, and many more things, right? Now see, why I've taken this particular data set, because this looks completely different when compared to the previous data set that we have seen, right? So how we can probably handle this? And over here you can see a lot of special characters like M. There'll be different special characters. There may be a question mark somewhere in between. Some other data set may not be clean. So how we can probably go ahead and clean the data set, that we will probably start with. Okay, so generic information. First of all, if I go ahead and see my df.shape, it is having 10,000 records with 13 columns, right? And if you want to probably see the general information, I can basically write df.info. This shows that almost all the features are basically object type. Only one feature, that is rating, is basically your floating type, because it is a numerical value. Then if you really want to see the summary of the data set, so summary of the data set, so for this we can basically write df.describe. So whatever will be the numerical feature, only with that summary we'll be getting. Right now, we just have one numerical feature, right? So all this information is definitely there. Now let's go and see whether you have any missing values, and we'll try to handle those missing values also. Dot sum, if I do the dot sum, then here I'll be seeing that in ratings, I really have many missing values. In type, I have one missing value. In current version, I have 8 missing values. And Android version, I have 3 missing values. We'll try to see, obviously from this, we can make a conclusion. Again, it's all about insights and observation. I'll not say conclusion, it should be observation. In EDA, we just make observation. Okay. So observation is that definitely the data set has missing values. Okay. So this is my information that is present. So I'm going to make it as a markdown. Okay. So this information is definitely there. Now what we'll do is that we will catch up every column, and we'll try to find out some or the other information out of it. Okay, so let's consider this reviews column. So if I probably go ahead and write df.head of the 2 records, right? So here there is something called as reviews column. I have actually checked this data set, and it's all about how well you properly analyze. Okay, I found out in this reviews column, right, by probably seeing in this particular data set, and obviously initially it becomes difficult, but as you go ahead and cleaning this, you'll find out all these kind of issues. So if I write, probably I want to check if all the values in numbers of reviews numeric. Okay, so definitely I have reviews, right? So if you, okay, forget about this. I will just go ahead and write df of reviews dot unique. So if I probably go and see dot unique, okay. So usually we see this kind of dot unique itself, right? In this dot unique, right, all these values that you will be seeing, it is basically in the string format. Okay, string format, right? Now, if I want to find out inside this, is there any numerical value? Because I could see that, okay, I could see that, and it took a lot of time to probably find it out. But I made that observation later on once we were actually trying to handle the missing values or trying to see the data set in detail, right? So if I write df of reviews dot str, okay, dot is numeric, and I'm just checking is numeric dot sum. So here you'll be able to see that I am basically getting 10840. That basically means all these values that are there, this is basically in the numeric format only, but it is in the string format. Okay, but the total number of records that were actually present, if I probably see the shape, it is 10841, and this is right now how much? 10840. So 840, definitely this all belongs to a numeric format only, but it is in the string. One column is basically not in the numeric format. Okay, then in order to find out how I'll find out, so I will basically write something like this. See this? I will copy this and I will try to find out over here. I'll just give one notation which is like this notation, which is like not of this, right? Which is not numeric. You just give me that specific record. So if I write df, so here I'm getting, and here the reviews is 3.0m. Okay, all the other values had this kind of values, right? Over here you had 3.0m, right? Now this is the thing, guys. This is the challenges that you will probably face when you are working with a real world data set. Somewhere something will be there, and sometimes you will not be able to even understand why this problem is happening, you know, because let's consider that I convert this reviews column into integer. Okay, then what will happen? See this. If I probably go ahead and write df of reviews dot as type, and I just make it as int. So here if I probably try to execute this, I'll be getting an error, right? See, 3.0m, and this is how I found out, right? And then probably I fixed this issue, right? Then we got this. Now for this, what we can do, we can basically drop it because the 3.0m is there, right? And I can also convert this into 3 million. So 1 or 2 records will have definitely this kind of problems in this. Okay. So always understand that this kind of scenario will definitely come. Okay. Now, obviously I want to delete this record. So what I will do, I will just make df underscore copy, and we are still in the data cleaning process. This is what we do in data cleaning. So let me just go ahead and write over here something called as data cleaning. Okay. I will make a cell which I will say it as data cleaning, because we are focused right now in data cleaning. We need to clean the records, right? So here I have seen this kind of instance. I'll keep this error like this. Okay. So here what I will do, I will make a df underscore copy so that I can make the changes in my original data set. Okay. Basically take a copy of that data set and probably do it. So I will write df.copy. Okay. Now inside this, what I will do, df underscore copy dot drop. So there will be a drop functionality. And which index I have to probably drop. Here you can definitely see this, right? 10472, right? So 10472. So here also I will say df underscore copy, and I will say dot index, and I want to delete this specific index. Just a second. It is 10472. This specific index I really want to drop. Just a second, guys. Yeah. This specific index I want to drop. I'll make it a little bit zoomed so that you'll be able to see this. Okay. So this specific index I want to drop, right? So if I write df of copy dot index of this, I will get that record and we'll try to drop it. So I will just go ahead and probably insert that in df underscore copy. Now, if I go ahead and execute the same thing and try to find out whether that numerical value is existing or not in the copy variable, okay, you will be able to find nothing will be there, right? So this kind of scenarios will come. This is the cleaning process, right? And I'm not saying that it is easy to find out, because you will only be able to find out when you probably check this, right? As type int, when you're trying to convert that into int, right? And that is where I got this error, and that is the reason I'm fixing it. Okay. So I hope you got an idea with respect to this. Now what we can do, we can convert this convert the reviews data type to int, right? data type to int. Okay. So here I will write df of copy of specific reviews. Okay. And I will say df underscore copy, and this reviews will be as type int, right? So done. And I will basically get over here. And now if I probably see df underscore copy dot info, you'll be able to see that one feature will basically be reviews. It will be an integer value, right? So I hope you are able to get or understand this. Okay. Now let's go and catch some other features which can be numerical, and we'll try to see whether we are able to get this numerical or not. Okay. So let's go ahead and see this. Okay. Over here you have one feature called as size, right? So if I probably say df underscore copy of size, so any changes, any data cleaning, I will basically do in this df underscore copy dot unique, right? So dot unique will basically give me, see, so many different unique values are there. And these are also like numerical values. But you have over here M, 8.0 M, that basically means million, right? If K is there, 1000, right? So obviously we cannot have this million, K, 1000 like this, right? We really need to convert this into a proper numerical value. So I have to probably change this M into probably millions, like triple zeros or 6 zeros, right? So all this kind of things will be definitely there, right? Let's say that in this particular case, what I can do, I can probably write this code. So I will write df of underscore copy, and here I will say size is equal to, okay, and I will write df underscore copy of size. Now see what I will do. You know how to probably remove that M, right? So I will write dot str dot replace, okay, and this replacing, right? If I probably replace this particular M with, let's say, to start with some 1 2 3 4 1 2 3 4, or let me do one thing. Let me convert this into K units. Okay. So whatever values will be there, I will try to convert this into K units. Okay. So if I want to probably convert this 19 million into K units basically means 1000. Then how I'll do? I'll basically write, so if I probably consider this as an example, see, what is 19 million? This is 19 million, right? So we have 6 zeros, 1 2 3 4 5 6. So this becomes 19 million, right? Now what I am actually going to do, I'm converting this into K units, right? Now if I want to convert this into K units, so I can probably remove this last 3. So it will be 19,000 K, right? 19,000 K. And that is what I'm actually doing, right? So this M, I'm basically converting only into 3 zeros, right? Initially, see, M will be 6 zeros, right? But if I want to convert this into K units, then what will happen? 3 zeros will go off, right? So this entire value is nothing but 19,000 K, right? It is just like K is nothing but 1000, right? So 19,000 K. This is nothing but 19 millions. This is equivalent to 19 millions, right? So both these values are actually equal, right? So this is what I'm actually planning to do. Oh yeah, we'll try to keep all the units in K because we have most of the values in K. Otherwise, you can directly convert that into numerical values itself, but I will just try to make it as K. Okay. So this will get converted into triple zeros. So here you will be able to see, I'll be getting 19,000, 14,000, wherever millions are there, that all values will be there. Okay. So this, I will go ahead and probably write df underscore copy of size. Now why I'm doing this, I want to make sure that my numerical features, right, it be in that specific manner, one specific format we will basically be doing. Now similarly, what I will do, I will go ahead and copy and paste over here with respect to K also. Wherever there is K, I will just remove that and keep it blank, right? So whatever K is, but that is the by default unit. Okay. So quickly we can definitely do this. Now one thing I will just do over here, df underscore copy of size. I want to also check whether it is basically having null values or not. So null dot sum. So here you will be able to see that 0 null values. Okay. With respect to unique, do you see anything other characters other than this? So there no unique is also there, right? So I think nothing we can see with respect to other unique values. Okay, one thing is there. See this? Now this is the problem, guys. You know, data scientist job is not that easy. If you get a clean data set, that is fine. But usually that clean data set will not be there. So what should I replace with this? Varies with device. So this is the value that is coming suddenly over there. So for this also we need to handle this, right? We need to probably handle it in a way. Now I can probably replace this with an AND value, and then later on probably change that nan value with something else, right? Something can happen, right? So this is the problem. Now I can probably see varies with device. So for this also I'll try to handle it. So I will just copy it over here and I will say instead of this K, I will take this entire varies with device. And this is cleaning process, guys. Trust me, everybody will think that this is easy. It is not that easy. And this I will try to replace it with np.nan. Let's say that I'm taking a nan value, right? And finally, what I will do, I will just try to place it over here and we will try to convert this into float. Okay. As type float, right? So done. Let's see whether it will get executed or not. Hope so it gets executed. So guys, here I can definitely see some error and it says that replaced must be a string or callable. So let's check what exactly this is. Okay, so here I don't have to use string because understand that we are not trying to split it or do anything as such. Directly we know that that entire thing is a string itself and directly we can write with replace. Okay, so here I've removed that and now if I probably go and see my df underscore copy dot info. So here you'll be having all the values and the size is also now a floating value. And if I probably see the null values also, the null values has also got removed. Okay. So quickly, if I probably go and show you df of copy with respect to size. Okay. Now you'll be able to see that there is a nan value over here, right? Now what we can do, we can probably replace this nan value with something else, right? And once we replace the nan value with something else, I think our work will be done. And that we'll probably do it in the feature engineering after we save this particular data. Okay. Now let's go with the other feature. Let's see what all features we can probably do it more now. See, every feature we need to see. Installs is also there, right? So if I probably go and see df.head, and here installs is there. Here also you can see, right? There are different values. So if I probably write df of installs, okay, df of installs dot unique, right? So there are so many different unique values with all this plus written over here. So we need to handle this obviously. And there is also one string value which is called as free. Okay. Similarly, if I probably go and see with respect to the price. So price is also one feature, right? So price is also one feature. Here also you'll be able to see dollar is there. Then again, dollar is over here. Everyone is there. See different values. So this is the challenge that you will see, right? I've already done this, so I'm able to quickly say to you, but when you start exploring as a data scientist, right, these all problems will be coming somewhere the other way. Okay. Now for both these features, two common things that I'm probably able to see, plus is there and dollar is there. Okay. So we'll try to replace this plus dollar, and I think there will also be like commas, wherever commas will be there. I think some fields are with respect to commas also. Okay. And there is also like everyone and all, right? So what I will do is that I will try to replace all the special characters with blank. Okay. So plus anywhere it comes, we'll try to replace it with blank. Dollars anywhere it will come, we'll try to replace it with blank, right? So that is what we are going to do over here. So first of all, I will just go ahead and write characters underscore to remove. What all characters we specifically want to remove? So the first character will be plus. The second character will basically be comma. The third character will specifically be dollar. Okay. And then I will just go ahead and write what all columns I want to clean. So columns underscore dot to underscore to clean. And here I will basically give my installs column. Okay. And price column. So we are finally cleaning the data set. Understand one thing. Okay. So for item in characters dot to remove. So every item will go ahead and take it and we'll iterate through all the columns for columns in columns to clean. And here what I'm actually going to do is that I'm basically going to write df underscore copy. Okay. And I will take the column and then we will just try to write df of df underscore copy dot not dot of column dot str dot replace all the special characters. And this characters is basically there in the item, and I will replace this with a blank, right? So once I execute this, column is there. Let's see, for columns, it is columns. Okay. Columns. So let's go ahead and execute it. So now finally, if you go and see df underscore copy of of this particular value, this installs.unique. Okay, sorry, we should have written underscore copy over here and underscore copy over here. Don't please try to do it in df, because any cleaning that we are doing, we are basically doing it in df underscore copy. So once I execute this, here you can see now I don't have any special characters like dollar or plus. In installs also, if you probably go ahead and see, okay, I will be removing that. So this is some of the cleaning process that I'm doing. The cleaning is basically done to probably find out if there is any special character. Now here also all the special characters is gone, right? This is so nice, so good. I've also used this comma, so wherever the comma is, that has also got removed. Great. And we have this entire clean data. Okay. Now with respect to this, now what I can do is that now I don't find out anything, right? Anything over here as a special character, everything is gone. Now we can convert this entire into an integer value. If there are any special character, it will give us an error. Okay, so df of copy of installs. Okay, and this we will try to convert this into a floating value or integer value, because here I don't have any decimal in installs. So I will write df underscore copy of installs dot as type, and here you will be having integer. Okay, and finally you will also be copy and pasting this. This will basically be my price, and here also we will have df underscore copy price as type integer. Okay, so price has a decimal values, so I'll not make it as integer, I'll make it as float. Okay, so done. Great. So if I write df.info, now my all the other features are also become, sorry, df underscore copy. So always this problem will happen, guys. So please make sure that you write it properly. So this is become integer, float, integer, and then you also have this price, which is becoming float. Okay, perfect. Now let's go and handle some more features like last updated. You can do line by line every features, but I'm just giving you an idea about it. Okay, so now we are going to handle the last update feature. Okay, and this still we are in the data cleaning process. So here I will write df underscore copy of last underscore updated, okay, dot unique. Okay, and here you will be seeing that I'm having January 7th, this. Now we really need to convert this data into date time. Okay, so if you know about date time, we will be able to convert this. It is very much simple. So for this I will be using pandas. So if I write pd dot to underscore date time, and probably give my values over here as df underscore copy of this particular feature last updated. Okay, so here you'll be able to see that I'm able to get all my date time. So I will try to convert this like this over here, and I will store it in the same variable df underscore copy over here with respect to my last updated. Okay, now obviously we have the entire date column, right? But I require the dates and the months also. So what I will do, I will create some additional column. So I will write df underscore copy of day is equal to df underscore copy of last updated. Okay, last updated dot dt dot day, right? So if I write dot dt dot day, automatically from this the day will get picked up, right? And similarly for month, what we'll do, we'll copy this entire thing, and here I will go ahead and write month, and here last updated dt dot month, right? So this is how we basically take out all the day, month, and year. And again for year, I will just use this. So I'm basically creating 3 columns, and then we can later on, if you want, you can drop this column also, that is last updated. So once I execute this, now if I go and see my df underscore copy dot info, so here you'll be able to see some very important information. See, first of all, the last updated has become a date time, and then this day, month, and year has become an integer values. Okay, so definitely good. I've done so much different kind of cleanings. Okay, and once we do some set of cleanings, right now, probably this, if I probably go and see df.head, okay, the top 5 records, here you can see app is basically a categorical feature. Category is also category feature. Rating has become noted into this. Size also we can do something like that. Okay, so size is also there. So if I probably go and see, is it df or df underscore copy? Just a second. So it should be df underscore copy. So here you can see categories, app, this will be numerical, categorical feature. Rating has become a numerical. Reviews, size, install, type is a categorical feature. Price Again, I'm having this floating values. Content rating becomes a category feature. This date has also get changed. So we are almost very good because we have done most of the data cleaning process that is required. Now the next step will be that I will try to save this data set. Okay. And always try to save this data set after cleaning also. So this will get converted into a CSV file, and the CSV file name will be, let's say I create a data folder and I will write Google cleaned CSV. Okay. .csv. So once I execute this, let's see, my error will coming. I have not created a data folder. It's fine. Not a big worries. I will create a data folder, new folder, data. Fine. Great. Let's go ahead and execute it. And now if I go and see my data folder, you'll be able to see this entire clean data. Isn't it amazing? Yes. So we have done the first task with respect to the data cleaning. That is so good. Now my second task will be that I will try to perform EDA after cleaning the data. And then after that we'll perform feature engineering. So I hope you are able to understand this video. I hope you like it. We'll divide this into multiple parts. Thank you. I will see you all in the next.